friends, you're welcome to your favorite learning channel, that is Royal Learning Channel. My name is Oluwatoyin. Today we are going to discuss about the chemical properties of Alkanol. The chemical properties of Alkanol. Then we look at uses of Alkanol, and the chemical test to distinguish between the three classes of Alkanol. We look at chemical properties of Alkanol. We look at uses of ethanol and the chemical test to distinguish between the three classes of Alkanol. So under chemical properties of Alkanol, we are going to look at these 8 chemical properties. We are going to look at these 8 chemical properties. Number 1 is combustion reaction. We look at dehydration. We look at amphoteric behavior of what? Of Alkanol. We look at oxidation reaction. Then we look at formation of alkoxy-alkane, which is known as what? Ether. Then we look at esterification reaction. Then we talk about atmospheric oxidation of ethanol. Then the iodoform reaction. So those are the chemical properties that we are going to discuss about the chemical properties of Alkanol. So let's first talk about combustion reaction. Then this combustion reaction is common to all organic compounds. Combustion reaction is common to all organic compounds. Then don't forget that when any organic compound reacts with oxygen, your product will be carbon 4 oxide and water. Your product will be carbon 4 oxide and water. So ethanol bonds with a non-luminous flame, to produce carbon 4 oxide and water vapor. Ethanol bonds with a non-luminous flame to produce carbon 4 oxide and water vapor. Then what is a non-luminous flame? What is a non-luminous flame? A non-luminous flame is a flame that burns blue with little light. A non-luminous flame is a flame that burns blue with little light. Then it does not produce smoke. Or soot. While luminous flame produces what? Smoke or soot. So a non-luminous flame is hotter than luminous flame. That is another differences between luminous and non-luminous. A non-luminous flame is hotter and it is more efficient than luminous flame. So let's see chemical reaction between ethanol and what? And oxygen, which is combustion reaction. Ethanol. Then the molecular formula for ethanol is C2H5OH plus oxygen. Then don't forget that I said that reaction between any organic compound and oxygen will give us what? Carbon 4 oxide and water. So therefore, our product is what? Carbon 4 oxide and what? And water vapor. Carbon 4 oxide and water vapor. Then we balance our chemical equation. We have 6 hydrogen here, 5 here plus 1. That is 6. So we put 3 here. 3 times 2 will give us 6. Then carbon atom is 2. So we have 1 here. We put 1 in order to what? To balance it. Then let's count our oxygen atom because we have more oxygen at the product side than our reactant side. 2 times 2, that is 4. Then 4 plus 3, that is 6 oxygen. So at this side, okay, 4 plus 3, that is 7. So we can add 3 here. That is 6 plus this one here. That is 7. So our equation is balanced. That is the what? Combustion reaction of ethanol, combustion reaction of ethanol. So let's move to dehydration reaction number 2. Number 2 is dehydration reaction. Then this dehydration reaction will take place in the presence of concentrated H2SO4. It will take place in the presence of concentrated H2SO4. And what is the function of concentrated H2SO4 in this chemical reaction? It serves as what? A dehydrating agent. Dehydrating agent, that is a compound or chemical that remove water. Then what is dehydration? Dehydration means what? Removal of water. Removal of water. So concentrated H2SO4 will remove water from what? From alkanol. From alkanol. Then under this dehydration reaction, we are going to talk about dehydration of primary alkanol. We talk about dehydration of secondary alkanol, and we talk about dehydration of tertiary alkanol. Then this reaction will take place in the presence of what? Concentrated H2SO4. Then don't forget that our concentrated H2SO4 will serve as what? Dehydrating agent. Will serve as dehydrating agent. That is, it will remove water from the molecule of what? Of an alkanol. It will remove water from the molecule of an alkanol. So let's look at dehydration of what? Of a primary alkanol. Dehydration of a primary alkanol. Example of a primary alkanol is ethanol. Ethanol. Then I'm going to use both structural formula and molecular formula to explain this chemical reaction so that we'll be able to understand it better. I will use both structural formula and the molecular formula to explain this chemical reaction. So let's start with the structural formula of ethanol. Make sure that your hydroxy group is at the adjacent carbon atom, attached to the adjacent carbon atom. Then the reaction will take place in the presence of concentrated H2SO4, which is your dehydrating agent. Then what is the purpose of this concentrated H2SO4? Is to remove water molecule from this structure, to remove water molecule from alkanol molecule. So let's remove water. So remove water molecule from the adjacent carbon atom. You remove your water molecule from the adjacent carbon atom. So let's remove our water molecule. You remove hydrogen together with this hydroxy group. Remove hydrogen together with this hydroxy group will give you H2O. So you have removed what? You have eliminated what? Water molecule. 2 hydrogen plus 1 oxygen will give us H2O. So we are left with what? Carbon atom with 2 hydrogen atoms, then the other carbon atom with 2 hydrogen atoms. So these are products now. So here we have hydrogen, then hydrogen. This one remain a single bond here. Then the second carbon atom with 2 hydrogen, because we have eliminated this. So we have hydrogen and hydrogen here. So with this, we will observe that this chemical bond, this one, it needs what? One more what? Bond to complete the number of what? Bonds that must surround each carbon atom. Don't forget that I said that in organic chemistry, each carbon atom must be surrounded with 4 chemical bonds. each carbon atom must be surrounded with 4 chemical bonds. So if you look at the first carbon atom now, it is surrounded with what? Surrounded with 3 chemical bonds. So it needs one more to balance. So you add one more bond to it. So to balance that what? 4 chemical bonds. So this one also has balanced 4 chemical bonds. So this is our product. So let's transform this structural formula now to molecular formula. They can ask you in exam to write it in molecular form. They can give you equation to balance in molecular form. So let's change this structural formula to molecular formula. So how many carbon atom here? 1, 2. That's C2. Then how many hydrogen? 1, 2, 3, 4, 5. H5. Then how many? Then with our what? Our hydroxy group. That's OH. Then our dehydrating agent, which is concentrated H2SO4. Then minus H2O, that is the water molecule that we have removed. So our product now is what? 1, 2. That's 2 carbon atom. How many hydrogen? 1, 2, 3, 4. Surrounded with 4 hydrogen atoms. So this is the molecular formula of ethene. So it shows that when ethanol is dehydrated, it will lead to the formation of what? Ethene. When ethanol is hydrated, leads to the formation of what? Of ethene. This is a primary alkanol. Dehydration of what? Of a primary alkanol. So let's talk about dehydration of what? Of a secondary alkanol. A secondary alkanol. So let's look at our example of a secondary alkanol. Then how will you recognize a secondary alkanol? That is when the carbon atom holding your functional group is bonded to 2 alkyl group. When 2 alkyl groups are bonded to the carbon atom holding your functional group. Now, the first thing, write the carbon atom holding your functional group first. So this is the carbon atom holding my functional group. So the functional group of alkanol is OH. So then surround it with 2 alkyl group, any 2 alkyl groups that you like. So at this side, let me add CH3. CH3 is an alkyl group, which is methyl. Then I would like to add C2H5 at this side. C2H5 at this side. So C2H5 is what? Is ethyl, is an alkyl group. So when 2 alkyl group, this is 2 alkyl group now. So when 2 alkyl group attached to the carbon atom or bonded to the carbon atom holding your functional group, you call it what? A secondary alkanol. So this is a secondary alkanol. This is a secondary alkanol. So let me open this chain to give us what? An open chain structure. 1 carbon atom with 3 hydrogen. So at this side, 2 carbon atom with 5 hydrogens. 1, 2. Then surrounded with 5 hydrogen. 4, 5. So I want to bring my functional group down. Then the hydrogen up. So I want the functional group to be at the adjacent side. So this is the structural formula for what? For a secondary alkanol. Then we want to dehydrate this secondary alkanol. In this structure, it is possible to have two products. It is possible to have 2 products. And let's see how it goes. So with our dehydrating agent. So what will be our product now? Now from this structure, I can displace or eliminate water molecule from two different carbon atoms. I can eliminate water molecule here, that is taking one hydrogen here with this hydroxyl group. The product that I'm going to get will be totally different from when I eliminate water molecule by removing this hydrogen and this hydroxyl group. So let's remove this hydrogen and this alkyl group and the hydroxyl group at this side, and see the first product. When I remove hydrogen here and hydroxyl group here, so this will be our product. Sorry, let me bring this arrow down here. So our products will be formed down. So from here now, I've eliminated what? Water molecule from this side. I've eliminated water molecule from this side. So let's see what we are left with. So at this side, one carbon atom with two hydrogen. So with a single carbon atom here, I've eliminated what? This OH. From this carbon atom, it remains only one hydrogen atom. Then followed by this carbon atom with two hydrogen atoms. Then the last one, this carbon atom with three hydrogen atoms. Now, check if each carbon atom is surrounded with 4 chemical bonds. So let's look at this side. 1, 2, 3. So this one needs what? It needs one more chemical bond to balance. 1, 2, 3, 4. Now let's look at this one too. 1, 2, 3, 4 balanced. 1, 2, 3, 4 balanced. 1, 2, 3, 4 balanced. So this is our first product. These are first products. So what's the name of this first product? 1, 2, 3, 4. That's prop-1-ene, or you call it propene. Prop-1-ene or propane. Sorry, 1, 2, 3, 4. That's but-1-ene. 1, 2, 3, 4. That's but-1-ene or butene. Then the second product, don't forget that I said that it is possible to remove this hydroxyl group and this hydrogen atom. Then at the same time, it is possible to eliminate this hydroxyl group with this hydrogen atom. So let's eliminate this hydroxyl group now. This hydroxyl group together with this hydrogen atom now. This hydroxyl group together with this hydrogen atom. Then therefore, we remove this one. Since we are eliminating just only one molecule of water, so we are going to eliminate OH and this hydroxyl group and this hydrogen atom. So what will be our product for this one? So the first carbon atom with three hydrogen atoms. Then the second carbon atom with only one hydrogen. Then the third carbon atom with only one hydrogen. Then the last carbon atom with 3 hydrogen atoms. Now, for the first carbon atom, it completed its own 4 chemical bonds. But the second carbon atom remains 1. 1, 2, 3. 1, 2, 3. So this one needs one more at this side. So this one now, 1, 2, 3, 4 complete. Like likewise this one. So the name of this product is what? Is but2-ene. Why? Because the "ene", which is the double bond, is on the second carbon atom. But2-ene. So it shows that when you dehydrate what? When you dehydrate a secondary alkanol, you are going to have two different molecules, of what? Of alkene. You are going to get two molecules of alkene whenever you dehydrate a secondary alkanol. So let's look at dehydration of a tertiary alkanol. Dehydration of what? A tertiary alkanol. Number 3 is dehydration of what? Of a tertiary alkanol. What is a tertiary alkanol? This is when three alkyl groups are bonded to the carbon atom holding your functional group. When three alkyl groups are bonded to the carbon atom holding your functional group. Now let's see. This is the carbon atom holding my functional group. Let my functional group, which is OH, be at the adjacent side. Then CH3 is an alkyl group. Another CH3 at this side is an alkyl group. Then if I put another CH3 here, that's an alkyl group. So 1, 2, 3. We have three alkyl groups bonded to this carbon atom holding your functional group. So therefore, this structure belongs to what? A tertiary alkanol. This is a tertiary alkanol. So let's turn it to an open chain structure. That is the first carbon atom with 3 hydrogen atoms. Then the carbon atom holding my functional group with another CH3. So the last one, CH3. Then what is the name of this product? 1, 2, 3. That's 2-methyl propan 2-ol. 2-methyl propan 2-ol. 2-methyl propan 2-ol. Then let's dehydrate. That is, let's remove water. Now, we are going to remove water from the adjacent carbon atom. We eliminate water from the adjacent carbon atom. So, water is what? Reaction between hydroxyl group and hydrogen atom. So, minus H2O. Now, when you eliminate water from this product, from this structure, so let's see what we are going to have after elimination of what? Of water. So, let's see our product. The first carbon atom with 3 hydrogen atoms. Then the second carbon atom with CH3, which is an alkyl group. Then the third carbon atom with 2 hydrogen atoms. Now this one needs what? 1 more chemical bond to balance. It needs 1 more chemical bond to balance. So that's 1, 2, 3, 4. 1, 2, 3, 4. So what's the name of this product? What is the name of this product? You can call it what? Number 1, this is an alkene. This is an alkene. It belongs to what? Alkene group. So therefore we have CH3, which is methyl on the second carbon atom. 1, 2, 3. The root hydrocarbon is propene. So therefore it will be what? 2-methyl 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 proptune proptune. Then this is an isobutylene. You can call it an isobutylene. And why did I call it an isobutylene? Because this is an isomer. This structure is an isomer of what? Of butane. Is an isomer of butane. When this CH3 attach to this carbon atom at this side, it will give you what? Butane. So this structure is an isomer of butane. That's why we call it what? Isobutylene, or you call it isobutane. So you can call it isobutylene. This structure you can call it isobutylene, or you call it 2-methyl proptune. 2-methyl proptune. So that is the what? The product of dehydration of what? Of a tertiary alkanol. Then you can turn this structural formula yourself to molecular formula. Let's turn this one to molecular formula. That's CH3 COH in brackets CH3, then CH3. So at this side minus H2O, then you put your concentrated what? H2SO4. So your product will be CH3, then C into brackets CH3 double bond CH2. So your chemical equation can come in this way, then it can come in this way. So let's move to the third chemical reaction, which is amphoteric behavior. Amphoteric behavior. Then the amphoteric behavior of what? Of alkanol shows that alkanol can act as an acid. It can act as an acid, then it can act as a base. So number 3 chemical process is amphoteric behavior. Then what is amphoteric? Amphoteric acts as an acid. Then it can also act what? As a base. When a compound, when a molecule acting as an acid, or it is acting as what? As a base, we call it what? An amphoteric reaction, an amphoteric compound. So ethanol, in this chemical reaction, ethanol will act as an acid. At the same time, it will act as a base. Number 1, let's see acidic reaction of what? Of ethanol as an acid. Then ethanol reacts with the most highly reactive metals. So ethanol reacts with the most highly reactive metal, that is the group 1 and group 2 metals, such as sodium, potassium, magnesium, and so on and so forth. Now, let me first take us to a chemical reaction under inorganic chemistry. Chemical reaction between acid and a metal. When an acid reacts with a metal, the metal will displace hydrogen from an acid and occupy the position of acid under inorganic. I'm taking us back to inorganic chemistry now. Under inorganic chemistry, when acid reacts with what? With a metal. Let's take for example, HCl is an acid, then plus a metal, sodium. Sodium is a metal. So this metal will displace hydrogen. It will displace hydrogen from this acid and occupy the position of hydrogen. So when this metal displace hydrogen, so the hydrogen will be what? It will be liberated in form of gas. Hydrogen will evolve in form of gas. So sodium will come in to give you, so hydrogen will be removed, then sodium will come in. So our product will now be what? So when sodium comes in, so it will now be NaCl. Then hydrogen will what? Will evolve in form of gas. So this is our product. So automatically, when a metal reacts with an acid, so the metal displaces hydrogen from an acid and occupy the position of hydrogen. So the same process will be applicable to this what? To this chemical reaction under organic chemistry. Now this time around, ethanol will be acting as an acid. Ethanol will act as an acid. Then ethanol, that is C2H5OH. Then it will react with what? With a metal. Don't forget that in this chemical equation, in this chemical reaction, ethanol is what? Is an acid. Ethanol is an acid. So whenever a metal reacts with an acid, the metal will displace hydrogen from an acid and occupy the position of what? Of hydrogen. So automatically, what will be our product now? So hydrogen will be removed. Hydrogen will be removed here. Then sodium will what? Will occupy the position of hydrogen. So our product will be C2H5O. Then sodium will come in, Na. Then the hydrogen will be what? Will be evolved in form of gas. So H2. So this one will give us a white solid. White solid of what? So what's the name of this product? This is sodium. Then C2H5 is what? Is ethyl. Then oxygen. We call it sodium ethoxide. So white solid of what? Of sodium ethoxide. So white solid of sodium ethoxide is formed. White solid of sodium ethoxide is formed. So this is our product. These are products. So this chemical reaction is applicable to what? To all members of what? Of alkanol. The only thing you need to do is what? Displace hydrogen from the what? From ethanol that is acting as an acid, and let that metal occupy the position of what? Of hydrogen. Let that metal, so you can bring any of this metal into this chemical reaction. So the hydrogen will be displaced, then metal will come in. Then you balance your chemical equation. You balance your chemical equation. So let's proceed. So let's look at the basic behavior of ethanol. The basic behavior of ethanol. Number 2, as a base. So when ethanol is acting as a base, it will react with an acid. It will react with an acid. Then don't forget that when a base reacts with an acid, it will form what? Salt and water only. reaction between base and acid gives what? Salt and water only, which we call what? Neutralization reaction under inorganic chemistry. Neutralization reaction. So an ethanol will be acting what? As a base here. An ethanol will be acting as a base. So C2H5OH. So it is acting as a base. Don't forget, it is acting as a base now. Plus an acid. So you can use any acid you like. I'm going to use hydrochloric acid this time around. So how are we going to form our product? Let's see our product. This C2H5OH will decompose to C2H5, then OH minus. So an hydroxy group carries what? Negative charge. So automatically this one will carry what? A positive charge. Then hydrochloric acid will decompose to hydrogen ion and chlorine ion. So we take positive, we combine with negative. So C2H5 we combine with Cl to give us C2H5Cl plus, then hydroxy group we combine with hydrogen ion to give us water molecule. So automatically C2H5 is what? Is a salt, then water. So when ethanol is acting as a base and reacts with an acid, the product will be salt and water only. Our product will be salt and water only. That is amphoteric what? Reaction of what? Of alkanol. So let's move to number 4, which is oxidation of alkanol. Oxidation of alkanol. So under this oxidation, we are going to discuss about oxidation of primary alkanol. We talk about oxidation of primary alkanol. Then we talk about oxidation of what? Secondary alkanol. So then under this chemical reaction, the tertiary alkanol does not undergo oxidation reaction. Then I'm going to explain the reason why tertiary alkanol does not undergo oxidation reaction. So let's proceed to oxidation reaction of alkanol. Then number 3 is oxidation, and number 4, oxidation reaction. So this oxidation reaction will take place in the presence of KMnO4, that's tetraoxomanganese 7, or acidified K2Cr2O7, which are oxidizing agents. So we are going to use either KMnO4 as an oxidizing agent or acidified K2Cr2O7. So these two ions, they are acting as what? Oxidizing agents. They are oxidizing agents. Then what is oxidation? What is oxidation? Oxidation is addition of oxygen. Addition of oxygen. So there is no how a compound will oxidize, and at the same time that chemical reaction there will be reduction. In a chemical compound where there is oxidation, automatically there will be what? There will be reduction. Then oxidation is what? Addition of oxygen and removal of hydrogen. But under this oxidation reaction of alkanol, we add oxygen and we remove water molecule. So let's look at oxidation reaction of what? Of ethanol. It will take place in the presence of what? KMnO4. Then your KMnO4 is what? Your oxidizing agent. So then what is oxidation? These are oxidizing agents. What is oxidation? Oxidation means what? Addition of oxygen. So you add oxygen from an oxidizing agent. Since this oxygen is not what? It's not an oxygen, it's not oxygen molecule. So you have to put it inside brackets because it is not an oxygen in form of gas. So you have to put it inside. So this one shows that this oxygen is from this what? Oxidizing agent. So this chemical reaction, especially for primary, this is for primary alkanol. For primary alkanol. Then this is, you know that ethanol is what? Is a primary alkanol. So I can use both molecular formula and the structural formula to explain this chemical reaction. So let me use structural formula. Now, the first thing we are going to do is to remove what? You remove water molecule. Then you bring in oxygen. Oxidation is what? Addition of oxygen. So we are going to add oxygen from this oxidizing agent. Oxygen will come in, then you remove water molecule. So you remove your water molecule from the carbon atom that is holding your functional group. Don't forget, remove water molecule from the carbon atom holding your functional group. So let's remove water molecule now. So you remove water molecule from this carbon atom holding your functional group. So when you remove water molecule, your structure will remain the first carbon atom with 3 hydrogen atoms. Then followed by the second carbon atom with what? With 1 hydrogen atom. Then don't forget that the reaction is what? Removal of water and addition of oxygen. So automatically this oxygen will come in. Then don't forget that in organic chemistry, oxygen is always bonded to the carbon atom with what? With double bond. Oxygen will be bonded to the carbon atom with what? With double bond. So this reaction is of 2 stages. This is our first product. The first product will give us what? Ethanol. This is what? Ethanol. Because CHO is the molecular formula for ethanol. So this is ethanol. So your product form here, you add oxygen again to the product form. This is the first stage, stage 1, then stage 2. So stage 2, you add oxygen again from your oxidizing agent. So this time around, you are not going to eliminate water molecule. Just add oxygen to this your what? Oxidizing. Add oxygen from your oxidizing agent to the product form from the first reaction. So let's add oxygen to this product now. So our product will be CH3, CH3. Then this hydrogen now, the double bond will open. You have C, then oxygen will combine together to give us what? 2 oxygen and 1 hydrogen. So that will be COOH. COOH, which can also be written as CH3, COH, and double bond. So this is the structural formula for the functional group of what? Of Alkanol. This is the structural formula. So you can write your product in this form or in this form. Then we can translate the first stage. Now I want to translate the first stage into what? Molecular formula. I want to translate this first stage into molecular formula. That is CH12 C2H5OH plus oxygen. So the first stage now, we are going to have CH3CHO. That is the first stage. Plus what? Plus water molecule that you eliminated. Plus H2O. Plus H2O. Because there is what? Elimination of what? Of water. Plus H2O. That is the first stage. Then the second stage now, your product form. Your product form here, which is what? CH3CHO. CH3CHO plus oxygen will give us what? Our product is what? CH3COOH. So which is known as what? Ethanoic acid. Our final product is what? Is ethanoic acid. Our final product is what? Is ethanoic acid. That is oxidation of what? Of a primary alkanol. Oxidation reaction of a primary alkanol. So let's look at oxidation reaction of a secondary alkanol. Oxidation reaction of a secondary alkanol. Oxidation reaction of what? Of a secondary alkanol. So let's take a secondary alkanol. Let's take a secondary alkanol. Then don't forget that oxidation is what? Addition of oxygen. Addition of oxygen. So under oxidation reaction in organic chemistry, there will be addition of oxygen. Then under alkanol, then you remove water molecule. Don't forget that you add oxygen. You add that oxygen to the carbon atom that is holding your functional group, and the water molecule must be removed from the carbon atom holding your functional group. That oxygen from oxidizing agent must be added to this carbon atom that is holding your functional group, and at the same time the water molecule you want to remove must be removed from this carbon atom holding your functional group. So let's add oxygen now from oxidizing agent. Then our oxidizing agent on the arrow. Now let's first remove what? Let's remove water molecule before we add oxygen. So H2, this hydrogen and this hydroxy group will be removed to give us what? H2O. So we remove water molecule. Then our products now will be, when we remove this water molecule here, when we remove hydrogen and hydroxy group, so we are going to have the first carbon atom with 3 hydrogen atoms. Then the second carbon atom with nothing, because we have removed what? Hydrogen and hydroxy group. So we have only 1 carbon atom here. Then the third carbon atom with 3 hydrogen. Then don't forget that oxygen will now come in. Oxygen will come in because it is addition of oxygen. We have removed water now. Then the oxygen must be bonded to the carbon atom. This carbon atom holding your functional group. Then don't forget that I said in organic chemistry, oxygen will be bonded to the carbon atom with 2 what? With 2 chemical bonds. So oxygen will be bonded to the carbon atom with 2 chemical bonds. Now, CO is the functional group of Alkanol. Don't forget, CO is the functional group of Alkanol. CH3 is an alkyl group, that's R, then CO. CH3, this CH3 is also an alkyl group, CH3R. So RCOR is the functional group of what? The general formula for Alkanol. Alkanol. So automatically, this is an Alkanol. This is an alkanol. So which alkanol, which member of alkanol? An alkanol with 3 carbon atoms. 1, 2, 3. An alkanol with 3 carbon atoms is called what? Propanol. Propanol. But the own is on the second carbon atom. CO is your own under alkanol. Alkanol. The own is on the second carbon atom. So you call it propan 2-ol. Propan 2-ol. So the name of this structure is what? Propan 2-ol. So a secondary alkanol will oxidize to what? To an alkanol. A secondary alkanol oxidize to an alkanol. Don't forget, a primary alkanol will oxidize to alkanoic. While a secondary alkanol will oxidize to alkanol. Take note of that. Then let's look at tertiary alkanol. Like I said that tertiary alkanol does not undergo oxidation reaction. Then I will explain the reason why. So what is a tertiary alkanol? This is when 3 alkyl groups are bonded to the carbon atom holding your functional group. This is when 3 alkyl groups are bonded to the carbon atom holding the functional group. So our target will be the carbon atom that is holding my functional group. This is the carbon atom holding my functional group, that is the hydroxy group. Then 3 alkyl group will be bonded to this carbon atom. 1, 2, 3. So you attach 3 alkyl group. Let me use CH3 here. CH3. Now, don't forget the rule from up. You add oxygen to the carbon atom that is holding your functional group. At the same time, you eliminate water molecule from the carbon atom that is holding your functional group. You have to eliminate water molecule from this carbon atom holding your functional group. So that is the first stage. Now, I cannot eliminate water molecule from this carbon atom because there is no hydrogen here that will combine with hydroxy group to give us water molecule. This one is CH3, that's an alkyl group. So you cannot remove hydrogen atom from this alkyl group and add it to what? OH. So therefore, you cannot eliminate water molecule from this carbon atom holding your functional group. Assuming that there's hydrogen atom here, you'll be able to what? Eliminate water molecule. That is OH will combine with hydrogen. But there is no hydrogen atom here. So there is no hydrogen atom that this hydroxy group we combine with to remove water molecule. So therefore, no feasible reaction. No feasible reaction. That is, tertiary alkanol does not undergo what? Oxidation reaction. Tertiary alkanol does not undergo oxidation reaction. So let's proceed to number 5. Formation of alkoxy-alkane. Formation of alkoxy-alkane. Formation of alkoxy-alkane. Number 5. Then what is alkoxy-alkane? Another name for alkoxy-alkane is ether. Then alkoxy, that is alkyl, oxygen and alkane. That is the meaning of alkoxy-alkane. Alkyl, oxygen and alkane. Then we produce alkoxy-alkane from reaction between two molecules of alkanol. We produce alkoxy-alkane from reaction between two molecules of alkanol. So we are going to use two molecules of alkanol to produce the alkoxy-alkane. Let me use a structural formula. This is an alkanol. This is ethanol. Then plus another molecule of ethanol. So at this time around, let the position of your hydroxy group be at this side from the second molecule. This is another ethanol. Then the only differences between this one and this one is the position of the what? Of the OH. OH is at this side here. OH is at this side. So formation of alkoxy-alkane. To form an alkoxy-alkane, you remove water molecule from the two molecules of alkanol. You displace water molecule from the two molecules of what? Of alkanol. So at this side, you displace what? Hydroxy group. Then you displace hydrogen from this side. You displace hydroxy group from this side, then displace hydrogen from this side. Then our product will be CH3, CH2, because the first carbon atom with 3 hydrogen atoms, then the second carbon atom with 2 hydrogen atoms, CH3, CH2, followed by oxygen at this side. We have removed OH, CH3, CH2. Then you join with what? With this oxygen. Then with this oxygen at this side. Then at this side, CH2. Then CH3. So that is our product. So what is the name of this product? Don't forget that alkoxy again is alky, oxygen, and what? And alkane. So alky and oxygen will give us alkoxy. Alkoxy. So what are you going to call this one? CH2. I can also change this product to CH2, 2 carbon atom with 5 hydrogen atom. 2 carbon atom, 3 plus 2 will give us 5. Then O, oxygen, then 2 carbon atom plus 5 hydrogen atoms. So C2H5 is what? Is ethyl. So you call it ethoxy. Ethoxy. Then this one will be from what? From ethane, the second member of alkane, because it's the combination of alky, oxygen, and alkane. Then the alky there is what? Ethyl. Then followed by oxygen, followed by the second member of what? Alkane, which is ethane. So you call it ethoxy ethane. So our product is what? Ethoxy ethane. Ethoxy ethane. So you can write your product in this form. So your product will now be C2H5O C2H5. C2H5. Then this one you can transform it to what? To molecular formula. You can change this structural formula to molecular formula. That will be C2H5OH plus C2H5OH to give us C2H5O C2H5. That is formation of what? Alkoxy alkane, which is also known as what? Ether. Then let's move to number 6, which is what? Esterification reaction. Esterification reaction. Number 6 is esterification reaction. Then the esterification means formation of ester. Just remove ester. Remove this. Formation of ester. Then ester is what? Ester is an alkanoate. Ester is an alkanoate. So esterification is what? Formation of ester. Formation of ester. Then what is esterification reaction? What is esterification reaction? This is a reaction. This is a reaction between alkanol and alkanoic to produce ester and water. Then is a chemical reaction between alkanol and alkanoic. Alkanol plus alkanoic will give you what? Ester and water. Now let's relate this chemical reaction. Let's relate this chemical reaction before I give you example on it. Let's relate this chemical reaction to inorganic. Then alkanol. Alkanol is an organic base. Alkanol is an organic base. This is a base, is an organic base. While alkanoic is an organic acid. While alkanoic is an organic acid. Then when a base reacts with an acid, automatically our product will be what? Salt and water. So ester is what? Ester is an organic salt. So ester is an organic salt. So let's take a chemical reaction. let's take a chemical reaction. Example of alkanol is ethanol, C2H5OH, plus an alkanoic. Let me use ethanoic, CH3COOH. CH3COOH is an ethanoic, while C2H5OH is an alkanoic. So therefore, you remove what? Water. Because our product will be what? Salt and water only. So you remove hydroxy group here, then you remove what? Hydrogen atom. So you remove hydroxy group here, you remove hydrogen atom. So this one and this one will combine together to give you what? H2O. Then plus. So here we are left with CH3COO. So automatically CH3COO we combine with C2H5 to give us CH3 COO, then plus what? C2H5, then plus OH plus hydrogen will give us what? H2O. So our product is now what? Ester and water. So let's name this product. Don't forget that under alkanoate, which is known as ester, under alkanoate, we always name our product from the back to the front. We name our product from the back to the front. So what we have at the back is an alkyl group. Why this one is the main what? The main alkanoate, the main ester, that is the root hydrocarbon of ester. This is the root hydrocarbon. Why this C2H5 is an alkyl group. Then C2H5 is what? Is ethyl. So we call it what? Ethyl 1, 2. An alkanoate with 2 carbon atom is called what? Ethanoate. So it is called ethyl ethanoate. So and what? And water. So our product now is what? Ethyl ethanoate and water. So let me give you one more example under reaction between alkanol and alkanoic, because they can give you any member of alkanol and any member of what? Of alkanoic. So let's take another example before we proceed to number 7. So let's take another member of alkanol. I'll use propanol this time around. That's C3H7OH. That's my propanol. Then let propanol react with butanoic, because it is a reaction between alkanol and alkanoic. So let this react with butanoic. That will be CH3 CH2 COOH. Then I can also write it as 1, 2, 3 C3H7. Let me write it as C3H7 COOH, because an alkanoic member with 4 carbon atom, 3 here plus 1, with 4 carbon atom is butanoic. Then an alkanol with 3 carbon atom is what? Is propanol. So we eliminate what? Water here. Then we eliminate hydrogen here. So hydrogen and hydroxy group we combine. Then C3H7, which is an alkyl group, we combine with what? C3H7COO. So our product now will be C3H7COO. It will combine with C3H7 C3H7, then plus, then hydroxyl group plus hydrogen will give us what? Water molecule. So we have produced another member of what? Of ester. So what will be the name of this what? Of this product? C3H7 is the third member of an alkyl group. That is what? Propyl. Propyl. Then this is our root hydrocarbon now. So we call this propyl. Propyl, because we always name from the back to the front. So let's name our root hydrocarbon. This is under alkanoate. So an alkanoate with 4 carbon atom, 3 here plus 1, that is 4. An alkanoate with 4 carbon atom is called what? Butanoate. So propyl butanoate. So the name of this product is propyl butanoate. Propyl butanoate. Then let's move to number 7. That's atmospheric oxidation of ethanol. Atmospheric oxidation of ethanol. Number 7 is atmospheric oxidation of ethanol. Atmospheric oxidation of ethanol. Then ethanol will oxidize to ethanoic acid and water. Ethanol will oxidize to ethanoic acid and water by oxygen in the atmosphere. By oxygen in the atmosphere in the presence of bacteria in air. The bacteria in air and oxygen will act on ethanol and convert it to what? Ethanoic acid. Not like combustion reaction of ethanol this time around. Truly, combustion reaction of ethanol is reaction between ethanol and oxygen. But this time around, we are using what? Atmospheric oxygen in the presence of bacteria. Atmospheric oxygen in the presence of bacteria. So, when ethanol, which is C2H5OH, reacts with what? Atmospheric oxygen. Atmospheric oxygen. It will convert it to what? Ethanoic acid. That's CH3COOH plus what? Plus water. That is our product for atmospheric oxidation of what? Of ethanol in the presence of what? Bacteria in air. In the presence of bacteria in air. Form reaction. Number 8 is iodoform reaction. Then ethanol is warmed with iodine. When ethanol is warmed with iodine and dissolved in sodium hydroxide, aqueous sodium hydroxide, a yellow precipitate of triiodomethane will be formed. When ethanol is warmed with iodine and dissolved in aqueous sodium hydroxide, a yellow precipitate of triiodomethane is formed. So let's look at the chemical reaction between ethanol and iodine. This chemical reaction is of two stages. So let's first look at reaction between ethanol and iodine. Ethanol and iodine. So ethanol, I'm going to use structural formula to explain. Plus iodine. So this iodine will eliminate, 5 hydrogen atoms. From this structure. It will eliminate 5 hydrogen atoms. Then there will be replacement. Of what? Of three iodine. So 3 hydrogen will come in and 5 hydrogen atoms will be eliminated. 5 hydrogen atoms will be eliminated. So let's eliminate 5 hydrogen atoms. So when we eliminate 5 hydrogen atoms, so each hydrogen atom will combine with 1 iodine. Each 5 hydrogen atom will combine with 1 iodine. So hydrogen plus iodine will give us hydrogen iodide. So it shows that we are going to have 5 molecules of what? Of hydrogen iodide. 5 molecules of hydrogen iodide. So we are going to eliminate 5 hydrogen atoms. That is, this hydrogen atom will go, this one 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 will also go. So we have eliminated 5 hydrogen atoms now. So what are we having from this structure? Our structure will now be the first carbon atom with 1 hydrogen atom. We are left with this 1 hydrogen atoms. This 1 hydrogen atom, we are left with this hydrogen atom and carbon with oxygen atom at this side. Then the oxygen will go with what? Double bond. Don't forget that oxygen is always bonded to carbon atom with what? With double bond. Then with 1 hydrogen at this side. Then the second carbon atom now. So all the 3 hydrogens that you eliminated from the second carbon atom will be replaced with what? With 3 iodine. Atoms. So this is our first product. That is the first product. Now the second product now, your product from here. Then they can ask you to name this product. CHO is the functional group of what? Of Alkanol. Then to the first carbon atom, this is the second carbon atom, because we have to name from our functional group. You name from the functional group. So this is your first carbon atom, this is your second carbon atom. So to the second carbon atom, we have 3 what? 3 iodine attached to the second carbon atom. So we are going to say 2, 2, 2, because the 3 hydrogen atoms are attached to the second carbon atom. Then triodo. Then an alkanol with 2 carbon atom is called what? Ethanol. So this is our first product. Then you can write your first product in form of what? In form of molecular formula. I can translate this one to molecular formula. That will be C2H5OH plus I2. Then we give us CHO, then CI3. CHO, CI3 plus 5HI. Then you need to balance your chemical equation. We have three what? We have 3 iodine here. We have 5 here. That is 8. So we put 4 here to balance our chemical equation. So our chemical equation is balanced. This is the first stage. This is the first stage. So our product here, then we add what? Sodium hydroxide. We then add sodium hydroxide to our product from the first reaction. So this is our product from the first chemical reaction. So I'm going to use this structural formula now. Oxygen with double bond, C. Then we have hydrogen. Then the second carbon atom with 3 iodine atoms. Then this time around, then we add what? Sodium hydroxide. Sodium hydroxide. So addition of sodium hydroxide to an alkanol will displace hydrogen atom from alkanol. So these products will decompose into 2. It will decompose into 2. So we are going to have CHO and CI3. Then this one need one more atom to complete, to balance. This one too need one more atom to balance, because this is the functional group of alkanol. So dash, something must attach to this side. Then this CH3. So the chemical bond here, something must attach to it. Then this one has decomposed to hydrogen and sodium oxide. Sodium oxide. So this hydrogen will combine with this to give us this hydrogen. Hydrogen will combine with this molecule to give us CHI3. So when hydrogen combine, it will give us CHI3. Then the alkanol group will then combine with sodium oxide. It will combine with sodium oxide to give us C. Oxygen here plus 1 oxygen here, that is 2 oxygen. Then the hydrogen at this side will be there. Sorry. Let's first take hydrogen, because something must attach here. So let's bring our hydrogen here. Hydrogen C. Then hydrogen C, then followed by oxygen. Then oxygen and sodium coming in. Oxygen with sodium. So our product is now what? Triodoethane. Triodoethane. Because this, if you draw the structural formula, it will give you the structural formula of an alkane. Then with 3 iodine. So triodoethane. And sodium what? Sodium methanoate. Sodium methanoate. Because this is the root hydrocarbon of what? Of an alkanoate. This is sodium methanoate and triodomethane. So that is the last chemical reaction under chemical properties of alkanol. So let's briefly talk about uses of alkanol, especially uses of ethanol. Let's talk about uses of ethanol. Uses of ethanol. So what are the uses of ethanol? I will just talk briefly about uses of ethanol. What are the uses of ethanol? Number 1, ethanol serves as what? As solvent for paint and stain. It serves as solvent for paint and stain. So what is the effect of ethanol as a solvent on paint or stain? That is, it dissolves and disperses the components of paint so that it can be easily washed away. It dissolves and disperses the components of what? Of paint, so that it can be easily washed away. Then ethanol can also be used in preservation of food. It can be used in preservation of food because ethanol is an hypertonic solution. When we relate it to biology, ethanol is an hypertonic solution. Then what is the function of an hypertonic solution? It withdraws water from a cell. Then any microorganism can only survive in the presence of water. So ethanol will withdraw water from cell membrane, and at the same time, since we call it an hypertonic solution, so the solution will be too what? It will be too concentrated for microorganism to survive. So that is why they are using ethanol in preservation of what? In preservation of food. Then ethanol can also be used to sterilize surgical instruments. It can be used to sterilize surgical instruments. That is in order to kill what? In order to kill germs. Then ethanol can also be used in cleaning what? In cleaning skin for injection. In cleaning skin for injection. In a medical laboratory or in an hospital, they will soak cotton wool in ethanol. They call it swab. So they use it to clean the surface of skin for injection. Another one, ethanol can also be used in production of some organic compound like alkanoic, like ethanoic. So we have produced ethanoic under what? Under dehydration and then under oxidation of what? Of primary alkanol. We produce ethanoic under oxidation of what? Of primary alkanol. So which shows that ethanol can be used to produce some organic compound like ethanoic acid. Then ethanol is also used in alcoholic thermometer. It is used in alcoholic thermometer due to its what? Very low freezing point, about -118 degree Celsius. -118 degree Celsius. Then another one, ethanol is also used, can also be used as fuel in gas lighter. It can be used as fuel in gas lighter. So those are the what? So those are the uses of ethanol. So finally, we talk about the chemical test to distinguish between the three classes of alkanol. Chemical test to distinguish between the three classes of alkanol. So the chemical test to distinguish the three classes of alkanol is called Lucas test. Lucas test. Take note of that. The chemical test to distinguish between the three classes of alkanol is called Lucas test. Then what are the constituents or the components of Lucas reagents? The components of Lucas reagents are concentrated HCl, that is concentrated hydrochloric acid and aqueous zinc chloride. So a mixture of concentrated hydrochloric acid and aqueous zinc chloride will give us what we call what? Lucas reagents. Lucas reagents. Then don't forget that we have three classes of alkanol. We have tertiary alkanol. Then two, we have secondary alkanol. Then three, we have primary alkanol. So when these Lucas reagents, don't forget that the constituents of Lucas reagents are concentrated hydrochloric acid and aqueous zinc chloride. So when this Lucas reagent is added to what? To a tertiary alkanol. When it is added to a tertiary alkanol, the solution will become turbid immediately. Plus Lucas reagents. So your product, it becomes turbid immediately. Then what is turbid? What is the meaning of turbid? Cloudy, not transparent. When something is not transparent like water, when it is cloudy, like when you add milk to water, so the solution will be cloudy. You will not be able to see through the solution. So we call this what? Turbid. So when you add Lucas reagent to a tertiary alkanol, the solution will become turbid immediately. Then if it is to a secondary alkanol, when you add Lucas reagent to a secondary alkanol, the solution will become turbid after 5 minutes. The solution becomes turbid after 5 minutes. So the solution becomes turbid after 5 minutes when Lucas reagent is added to what? A secondary alkanol. And lastly is what? Is primary alkanol. So when Lucas reagent is added to what? A primary alkanol, there will be no feasible reaction. So for this one, plus Lucas reagent, so no what? No feasible reaction. So there will be no feasible reaction. So we have come to the end of today's class. Remember to share this video with your friends. Subscribe to Royal Learning Channel, and you can watch this video at your own convenient time. See you in my next video. Bye.